Okay, welcome guys. This is a panel on ground meets cloud, and I'll hand things over to you, John. Take it away.
Okay, great, thanks. I've got a number of esteemed colleagues here who I won't even attempt to introduce because they've either already spoken today or they're well known to the world or both, and I would only butcher it. But it's an interesting time in the industry because as the first presenter noted, we've got a lot of transport capabilities now that maybe we didn't have years ago. Public internet for sending something to Australia. A few years ago, you would not have put that on your list of things to try, and yet turned out to be the thing that worked. So this all comes to a head when we start talking about how do we use cloud-based infrastructure to do television. Now, the pandemic caused us all to do a lot of things that we kind of lashed up and tried, and over the last year or two, many things have been tried and many things have worked, which is fantastic. But of course, the universe of standards and writing this stuff down, we're now trying to catch up to which things worked and which things are very which things are new and still experimental, and how do we move the ball forward to regularize some of these things we did in the last up. So one of the things I wanted to start talking about is just the current state. What are the things people are doing to get to and from the cloud, or to intermix ground and cloud production today? And Kieran, I'm going to kick that off to you because I think you've been in the middle of a few of them.
Yeah, I guess there are a number of proprietary and open standards-based approaches that people are using to interconnect different devices. Generally speaking, in the compressed domain in some shape or form. So a simple way is exchanging transport streams between different VMs with some error recovery protocol. This is not new in some respects. Transport stream over IP is probably 15, 20 years old now, nearly. And there are also obviously proprietary approaches with lightweight compression, such as NDI. Probably not unfair to say low to mid-end at best. NDI is based around MPEG-2, so it's inherently 8-bit, for example. I think it does do 422, but only 8 bits. So, but again, closed proprietary ecosystem. And there's also obviously a lot of cloud production in the OTT space. And I think some of the technical challenges are much simpler in the OTT space, in particular around linearization of, in the end, producing a valid transport stream at the end for broadcast. John in the meeting, I think, refers to something like the clock, the line buffer on a switcher is 8 microseconds long or something. Something like that is line, and the OTT guys don't really have to care about this, so they can do lots of things with protocols not really designed for linear video, like RTMP, etc.
Yeah, I think that mirrors our experience. We've done a number of cloud-based or otherwise hosted playout environments for customers, and generally the getting out of it is always currently transport stream at some rate. And I think as an industry, we've had 25, 30 years of experience, 95 at least, doing transport streams and getting them to and from places over IP, and it's a really well-trodden path. Now, there's a bit of balkanization in the world right now between, there's RIST, ZXI, SRT, True-7, FEC plus -7, -7 instead of FEC, and there's probably others as well. And so, Rick, as a customer, how do you make sense of the baffling array of options, or is it really right now when you do it, you just work down the table on both sides and figure out what the common meet point is?
That pretty much sums it up. It's a matter of what everybody has and what's readily available. We're trying to bring some standardization to it, but right now we're using a little bit of most things. Sometimes it's just a matter of what a client has. Sometimes it's a matter of what's available at one end versus the other end. So trying to bring some order to the madness is the hard part.
You know, that makes it just like everything we've done for 30 years, right?
Yeah, well, you know, now it's OTT and, you know, streaming delivery platforms. You know, 15 years ago it was videotape formats. You know, it's the more things change, the more they stay the same.
Now, as a consumer, when I watch television, which I admit I don't watch a lot of television, when I watch television, I often see kind of these awkward pauses and, like, you know, black to airs that are longer than I ever would have seen in the past. Are those some kind of artifact of latency between the person running master and what they see and what they're controlling? Or is that just the new normal of acceptable?
Well, it depends what the show is. I mean, obviously in local news, you'll accept stuff that, you know, is not quite as acceptable at the network level. You have latency in terms of the talent. You have latency in many cases in terms of the operators. A lot of the people in the control room aren't in the control room for a lot of shows. So they have their low latency view screen that they can look at, but their higher resolution, higher quality may have some latency depending on where they're looking at the moment. We had an interesting situation last week on the Late Show, where there's some things now that we're going to be stuck with. We had a guest who could not be in the studio due to scheduling, but Zoom doesn't necessarily cut it anymore. So we had a remote guest with a full production in a remote studio at full production quality, integrated into a virtual background, so that she could be interviewed as if she was there in the studio, even though they did, you know, it was clearly obviously a virtual background. So we can't get away from Zoom, even if we want to. We've gotten used to the point of people who aren't able to make it to the studio for whatever reason being on air. So part of the question is, how are we going to live in that world, yet at the same time up the quality so it looks like a professional broadcast TV show and does not look like somebody on Zoom, even if they're sitting somewhere in front of a green screen?
Well, when we first transitioned from SD to HD, if I just put on my gray hair, one of the things we discovered pretty quickly is that you couldn't really build a show that had SD elements and HD elements and have it look right. That it just having some HD elements made the SD elements look rough. Is there a similar effect with these, you know, with like you just described, where if you have a studio show and you start putting in insets, that those insets have to look as good as the studio show?
Yes. If you're going to have that level of quality, and we're not going to accept, you know, Zoom type quality anymore, we need to do Zoom type functionality, but at a pure broadcast quality level. Full frame rate, full resolution, proper lighting, all that nasty stuff. Okay. And have people do it from wherever they happen to be. And
is talent adapting to latency, or do we have to get back to a latency environment that can be managed by people who aren't necessarily as trained?
It depends. If it's a new stand-up, you can get away with latency. But sometimes when you start really interacting, whether it's one person cutting off somebody else, people joking with one another, if there's latency, sometimes you can't, you know, cut in on the person because the latency makes it not time out. And you run into that. I mean, like I said, ironically, with comedy, whether it's comedy shows or comedy bits, where timing is everything. And the latency can mess up someone's comedy timing.
So, Mr. Dale, is latency and average picture quality going to be with us forever, or is there a technology solution that's going to help?
Thanks for that that key there. Yeah, of course, we've been, I think everyone here has had some experience with JPEG 2000, and that's become sort of a de facto standard for the broadcast high-end contribution content coding. And of course, the VSF has just finished work on JPEG XS, which takes the latency component down considerably from what JPEG 2000 offered, which was generally 90 to 100 milliseconds. And now we can see latency for high quality coding down to 2 or 3 milliseconds, which is essentially no latency. So when we look at these type of applications, we mentioned before that, yes, transport streams have been around for a long time. And I think the VSF started working on Coder Practice 3, and that was probably more than 20 years ago. But the work that we've done on JPEG XS, that low latency codec can be applied over MPEG-2TS transport stream over 2022-2, or over 2110 in a more production friendly environment. And also, I believe a big advantage over JPEG 2000 for this low latency codec is it is much more friendly in a compute environment, so much more friendly for cloud applications. So I hope that gets some of that, some insight into what we've been doing for the JPEG XS standard.
Yeah, I mean, certainly it, as when we run things in, pure software and hosted environments, the downside of JPEG 2000 was that it took a, really serious chunk of computing just to catch or to throw. And that's been the promise of JPEG XS. And I think it's, bearing out in practice. I mean, that it takes a lot fewer cores or a lot less, memory bandwidth to catch it or throw it. Now, the computers have also gotten better over the years, but this does give us a path to have a reasonable latency, but there's still kind of the organizing principle. How do you catch and throw these feeds from a, arm's length parties trying to do a transactional business? I want to book a copy of the hockey game next Tuesday. How do we organize that technically in a way that doesn't drive everybody mad? And I know, Andy, you've been contemplating that quite seriously.
Sorry, I just missed the last bit of that. Say again. I'm packet loss.
Oh, it was right over the plate. It was. All you had to do was play. Oh wait, that's baseball. You don't play baseball in the UK. Whatever the cricket equivalent is, the pitch that
I'm actually here at Twickenham, the home of English rugby. So I'm actually live at a sporting ground, but obviously the connectivity is not all it could be to here.
Sorry. The question was about, we were talking about JPEG XS and its low latency and it's wonderful and it's cloud fit for, computational purposes, but getting there, especially if it's packaged as, say, 2110, we think of 2110 as a ground-based system with tight timing and all this, but I understand there's been a fair bit of work on adapting that and saying, how do we use that in a connecting facilities or connecting ground to cloud kind of sense?
Yeah, absolutely. So XS, I mean, I'm very pleased to see the TRs that have come out from the VSF family in the last few weeks. We've actually, I think we deployed our first XS solution, albeit a pre-standards version 2 years ago. So actually, I would go as far as encouraging people to say, actually, the technology is well proven now. We've actually been doing it for quite a long time. And the exciting thing for us has been, using -22 of 2110 means actually having it part as a production ecosystem. I think when we were started, when we were evolving the 2110 family, and someone proposed, a -22 for compressed video essence, I was quite skeptical initially, being a bit of a purist. But actually, in that time, since that was proposed maybe 3 years ago, we've actually moved to this world of distributed production where we're trying to interconnect multiple locations, quite often internationally. We've done a big deployment where we've got, I think, 14 different countries in Europe, all connecting via JPEG XS. and actually working as one. And as John D just said, the latency from the compression perspective is negligible, because as soon as you've gone a couple of 100 kilometers, that is the transit delay that becomes dominant. So you've almost got like roughly a 10-to-1 compression, which is costing you nothing in terms of latency. And what we've been trying to do in one of the other activity groups, which we'll talk briefly summarize later, is actually talk about how we actually carry 2110 both between facilities and to and from cloud infrastructure. And JPEG XS has actually fits very nicely on that wide area interconnect, whether we're going facility to facility or event to facility, or facility or event straight into cloud infrastructure. And we've been building templates for the use of XS in all of those applications.
Right. Now, one of the interesting things, you can use XS to get to the cloud, and that's, I think, a nice low latency path that is, going to help with some of the talent challenges and, frankly, just operational challenges that are latency induced. But many of the cloud applications right now are kind of a single vendor application, and you put it up there and you get video to it, you get video from it, but it on its own, it's kind of a single ecosystem. And I'm hearing a lot of interest in the world now and trying to expand into saying, no, I'd really like to stand up a whole ecosystem in the cloud where I get my content to it. Maybe it goes to redundant, to both an ingester and to a production switcher. Maybe it goes also to an ISO recorder. Maybe it goes, somewhere else. And then being able to freely kind of mix, match, and interconnect applications, possibly even from different vendors, in a cloud infrastructure with some kind of, approaching the same freedom that you can match and mix things on the ground. If you build a ground facility today, it's okay. You have Sony cameras and a grass mixer and somebody else's this or that. You expect it all to work. And getting to that same level of multi-vendor interoperation when catching and throwing between instances in a cloud environment seems both a great objective and pretty far out at the end of the arm right now. So I don't know, Kieran, can you comment on what's the state of play there? I know Amazon has certainly done a lot of work on CDI and published.
So John, I would internally I make the joke that what you've just said is in our company that's the last unsolved problem in broadcasting. I think I say all problems have been solved in broadcasting apart from cloud production. So I think that is the holy grail. But unfortunately, we're quite a way there. But as you sort of allude to, people like Amazon are coming along with protocols such as CDI. So for those who aren't aware, CDI, as the name kind of alludes to, is an Amazon specific video transport protocol using the technologies that they have available in their cloud for reliable packet delivery. So first things first, the things that are different compared to sort of transport streams and NDI, high bit rate uncompressed flows, so on the order of gigabits, whereas transport streams are in the tens, NDI is in the low hundreds. Those are relatively solved problems in IT. High bit rate gigabit flows involve, although they do exist in big data and other things, use technologies such as RDMA, which inherently are cloud vendor specific. The cloud vendors understand the way their networks are driven, built and operated, but also timing. Find big data providers don't really care whether big data arrives in 40 milliseconds or 80 milliseconds, whereas we obviously do. That's a dropped frame versus a not dropped frame. So inherently, this technology is cloud specific, and CDI is, I would say, a good step in the right direction towards sharing uncompressed content between different cloud VMs. And the work in the ground to cloud activity group that we'll talk about, I think, tries to refine this. So a stricter timing model. As I kind of alluded to at the beginning, the thing at the end has to linearize everything for traditional broadcast. Therefore, it needs to have strict timing requirements. Unlike the ground, we don't have things like PTP. We have NTP, and that NTP implementation could vary between cloud vendors, in particular the leap second smear. there are lots of challenges, and the ground to cloud activity group ideally will come up with a mechanism to do that. I guess you'll find out more in the next presentation, but pixel formats, 2110 pixel formats are not friendly in a compute environment. This is something we're trying to fix in the group. Lots of interesting challenges, to be honest. But it's pretty clear, just like 10 years ago, IP production was going to be the way forward. Cloud production is going to be the way forward in the future. And the current pandemic has really accelerated that.
Yep, I know, Andy, you've had a bit of time to play with some of this stuff as well and do some work there. What do you think where do you think we'll be a year from now on?
Yeah, it's a good one. So
application interchange.
Yeah, I think the work that AWS did in terms of putting what their if you like proprietary stack on GitHub and actually making that what they've done public has helped. And within GCCG, I think we are about to revisit what AWS have offered in the light of the requirements we've now gathered that we want from a perspective of interconnect. But I think one of the fundamental things that I think it's important to understand is the reason that we're having to look at this virtual interconnect, because we have honed and perfected and to continue to perfect 2110 over the last few years, but that is still inherently a highly linear, it has to be by necessity of UDP, a highly linear flow of data representing all of the media essences. Once we get into a compute environment, be that an AWS public cloud, or there are others available, or a private compute infrastructure, then handling linear data flows like that is just not the way compute likes to work. And also handling data with integrity, chunks of data, which is the way compute likes to work, 2110 just isn't cut out for that. So once we've got into the cloud in what I would call a linear manner, we have to actually do demarcation and actually move into a different way of handling the data chunks, if you like, of the media that we want to hand off. There's two things we need. Kieran hinted at it just now. They need to be transported or handed off with integrity. That's one important thing, and it needs to be time bound. Now, compute doesn't have quite the same, as we know, linear time bound approach that other infrastructure does, but we still need that time bound manner to be able to do that. But so what we're trying to do there, if you like, the holy grail of what we're trying to find is the definitions of how we can hand off data chunks in an interoperable manner that actually allows compute to work very friendly and not have to go back to the concept of putting everything back into this very compute unfriendly linear 2110 type environment.
Right. I mean, certainly 2110 was conceived through the lens of interoperating with the world as we knew it, where everything kind of proceeded in frame locksteps and everything was synced back to time. And at any point you could go back to SDI and back forward. And that's great in terms of modernizing the infrastructure of ground-based plants. But the cloud environment, we have the opportunity to rethink how we time things. And so that's been, as I'll mention later when we talk about the ground to cloud working group, a big part of our work over the summer was figuring out that time, how to keep track of time without being rigid, but still providing bounding, because at some point you do have to create a linear sequence of images that you present to the viewer's eyes. And so you can play with time and be fast and loose all you want in the middle if we do our job right. But in the end, we still have to put it back together and linearize it to comply with the codecs and other things that are going to get it home. And that's been the challenge, is finding that boundary line of when can we be fast and loose, and how do we keep track of how loose and how fast, and how do we guarantee that at the end of that chain of loose things that it can all line back up and linearize for delivery. Because the delivery systems, they still expect the notion that frames have frame times and that they're, happen in a sequence.
Yep, absolutely.
So
I think the other thing we need to think of, and I'll hint at it a bit later on in my presentation, is the orchestration of this, because I think we're starting to think about, well, I've been thinking about continually for many years, how we actually manage time in general through systems. But actually, when you've got compute functions that are delivering things in a nominal compute time, but you actually need to do a budget of how long things are going to take, actually overseeing the entire chain of compute processes is something else that we need to actually start thinking about. How we're going to do that, or how we're going to provide enough hooks for people to do that in a manner that actually is compatible.
Right. I mean, if I look today at, setting up a pipeline of things using CDI or some similar technology, and I ask my, colleagues who write the code, because I don't write a lot of code anymore, I say, show me how you set this up. And they go in a tool and a control panel and start pulling down pull downs and clicking on stuff. And I look at it and I say, that's how you do it. That's not how it's going to work in a live television environment.
Yep.
We need to get to where that stuff is scripted and automated in a hopefully not completely bespoke way. And this has got to be true of all the applications. We do a lot of hosted applications for traffic and billing and scheduling, where we've got, Ansible scripts and Terraform things that, turn it up and turn it down and instantiate it. And we have to kind of figure out what are the equivalent operations in the television world, and how do we get to where part of delivering an application is delivering the whatever it is. Was it a Terraform plugin? Is it an Ansible script? What is it that is the standard startup and teardown for an application? And we just have to develop standards and practices as an industry for what that means. We can't expect everyone to write stuff from scratch. So John, I know you were thinking about this problem as well, the orchestration and so forth. Is it the same everywhere?
Yeah, I would say that it would be a great service to the industry if we could come up with some uniform ways to at least address this issue in terms of some standard APIs perhaps, or interfaces, so that it would allow control of the workflow or the process in a uniform way, and not have to develop so many different applications. If we look at today in the non-cloud space, especially in the wide area space, there are so many different ways to address control of the signal plane. And the AMWA NMOS group has done a great job in the studio of formulating APIs, and I think Andy and the WAN group has done some work in looking at how to apply that perhaps in the WAN space. But certainly in the cloud space, if we could have some uniform standards there, I think that would be a great help, so that we don't reinvent the wheel 100 different times like what has gone on in the past.
Yeah, for sure. I think, one thing in a few minutes, or actually later today at about 2:15, you're going to hear report outs from 4 or 5 different activity groups. And they, funny enough, Andy chairs one of them, and Rick chairs one of them, and I organize one of them, and John Dale organizes one of them. And they are, and I think Kieran's probably in like all of them. So and each of them is picking at sort of part of this problem, and we've been doing this in parallel kind of on purpose, because it's just difficult to move each piece. So we've made a couple of teams and we're moving parts in parallel, but we do talk and keep them organized together. So hopefully what comes to your mind after you hear the report outs of the 4 groups is not that we're going in 4 different directions, but actually that we're going in 4 coordinated directions, because that's certainly our intent. And so, Brad, I think we've brought it in on the dime, and you're back on timeline.
Wonderful. Thank you so much. Great discussion. I'm especially just personally grateful to see talking about transferring in a DMA type environment. I think, we've done transport moving stuff in, I guess MPEG for a long time. And this DMA oriented sort of transport, I think, is going to be in quite a few of our futures going forward. So anyway, Great panel. Thank you to our panelists. And John, thank you for putting that together.